astronauts left this on the surface of the moon. And that thing holds some reflectors. And why do we care if there's reflectors on the moon? Because from our 107-inch telescope, we shot a laser at the moon. Aha! Here's a picture of the laser going to the moon. We shot a laser at the moon. Now, it took a little bit of hunting around to get the laser light to hit a reflector that's this big at a distance of 250,000 miles. But eventually they hit it, and then it had to be the right kind of reflector. If it was just a mirror, think about this. Laser light would have come in from Earth, hit that mirror at some angle, and reflected off into space, never to be seen again. That's not what our reflectors are. Instead, they are prisms that are called retroreflectors. And what that means is, this is my prism. I know, it looks like a gang sign, but it's a prism. Light comes in from any angle, it reflects internally, and it returns right back to its source. So, once we hit the reflectors on the moon, some of the light came back to our telescope. We could send a pulse of light to the moon, and it would come back, and we could time that pulse and determine very accurately the distance from the Earth to the moon. So that process is called Lunar Laser Ranging, and it was something we started right here with our 107-inch telescope. We continued doing laser ranging with this telescope for a number of years, and then eventually the laser was moved to our other mountain, over to Mount Folks. And then several years ago, lightning struck the telescope, and the decision, and I think also funding ended, so those things happened at about the same time. The decision was made not to repair the telescope, but we are continuing, and we will be doing more laser ranging in the future, and I will get to the reason why in a little bit. I want to talk about the 107-inch telescope right now. When it was completed in 1969, it was the third largest telescope in the world. So we like being up there near the top. I don't think we've ever been number one, but whatever. Anyway, so this is kind of the view you're going to get. One of the things that, we have these beautiful pictures of these telescopes where the dome's open, you can see the light coming in. We are not going to open the dome during the day. We have a pretty strong rule against doing that, but we do open the domes during the day if there's a fancy photographer coming to visit. So that's why the domes are open in some of these images. So anyway, there's our 107-inch telescope. We will go there, we'll talk about how it works and who gets to use it, and we'll probably be allowed to move it around, which is always really fun. So we will see that telescope, and then after a number of more years, we built and completed the Hobby-Eberly telescope. Hobby-Eberly telescope is on our other mountain, on Mount Folks. It's in this shiny silver dome. And the Hobby-Eberly telescope is one of the largest telescopes in the world. Not the largest, of course. It's number 2. The Hobby-Eberly telescope is 10 meters across and 11 meters high. And the largest telescope in the world is the Gran Telescopio Canarias in the Canary Islands. That is 10.4 meters across. So it beats us by this much.
It's until the one in Chile is going to be.
Until the one in Chile, yeah, and the other one, yeah. So it's always when our Giant Magellan telescope gets completed, then maybe we'll be number 1 at least for a week. So the Hobby-Eberly telescope collects and focuses 10 meters worth of light using an array of mirrors, not just one giant mirror, but a whole bunch of small ones. So here, these hexagons that you see, these are the mirrors. This picture was taken from an angle that we will not get on the tour. We're going to be down below, looking up at the mirror, and we won't get this view, so I wanted to make sure you saw. Each of these hexagons is a mirror. Okay? And each mirror is curved a little bit, and when we put it all together, we have a 10-meter wide curved array of mirrors. If we continued adding hexagons, we'd end up with a giant soccer ball, sort of. Okay? Does that make sense? All right. So 91 hexagonal mirrors, and out in front of the visitor center, we have models of our 3 big telescopes. We have a big round circle of concrete that is the size of the 82-inch telescope. We have a slightly bigger round circle of concrete that's as big as 107 inch. And then we have 91 hexagonal chunks of concrete that are the size of the Hobby Everly. And I would encourage you to stop and take a look at that on your way out when we head out for the tour. Anyway, so that's our third telescope, and that is where our tour is going to start today. We're going to start at the Hobby Everly telescope, and the reason for that is that it's winter time. You probably knew that. And in winter time, the sun sets early, and the team at the Hobby Everly telescope gets the telescope ready for the nighttime operations early, especially on Saturdays. On Saturdays, somebody comes up at maybe 4 in the afternoon, turns off all the lights in the dome, and makes it so we can't see the telescope. So we like to get there earlier before all the lights get turned off. So we're going there first, and then we'll go over to the 107 inch and see that telescope and watch it move and stuff like that. So that's our Hobby Everly telescope. There's one more telescope I'd like to talk about, and that is our giant radio telescope. This is our 12-meter geodetic observatory radio telescope. And it's just behind the visitor center. I hope you noticed it. Yeah, it's not a satellite dish. It is a telescope. And the McDonald Geodetic Observatory is a relatively new entity here at McDonald. It is, it and other geodetic observatories have been placed all around the globe to do studies of the Earth. So we're using astronomy to learn about the Earth. And the radio telescope, what it does is when it's running, you'll see it move and it'll be pointing at things, and it moves pretty often and pretty fast. That's fun to watch. Okay, so my one rule for standing out here is nobody stands on the wall. Nobody feet. Let me call in. I see 37 people here. All right, well, I hope you like the view here. Isn't it good? Why do you think McDonald Observatory is a good place to put an observatory? Why do you think this place is a good place? Dark skies. Dark skies? What do you think? Far away from humans? I'm seeing humans all around me.
Over a mile high.
Far away from big population areas.
Maybe like
Andrew, right? What do you think? Not as much light. So I'm hearing dark and not as much light.